We are going to find the volume of this light bulb, and it's a light bulb picture that's just been imported into Geometer Sketchpad. And to find the volume, I am first going to take a look at this outer shape. I have placed the light bulb so that the the origin is at the midway point, roughly, and it also is sort of at the point where the metal becomes glass, part of the light bulb. We are just going to be looking at the glass portion for volume. I am noticing here this portion looks like it may be parabolic in nature, so my first step is to find a parabola that matches that portion, and then I will deal with the remaining part of the light bulb. The first thing I'm going to do is create some segments. And I'm choosing to do 3. Each of these will represent a part of the parabolic equation. Each segment's length will represent either A, B, or C in the standard form y equals ax squared plus bx plus c. And I have the 3 segments now. The points are labeled A through F, and I am going to need to measure the length of each segment, since its length is what will be used for the formula for the parabola. Once I've cleaned up my screen a little bit, put these in order of A, B, and C as far as how I'm going to use them, I do need to go up and plot a new function. This will be the equation for the parabola that I will be using, and what I'm going to do, instead of putting in values for A, B, and C in standard form, I'm going to use this distance for my A. And when I add the bx, I've actually found from messing around with this that subtracting the measure of segment CD gives me a much more accurate parabola. And then add my C. So the equation that I have here is ax squared plus bx plus c. There's a parabola that clearly does not fit this curve, but hopefully by moving my segments around, I will be able to find one that does. And I know that I'm going to need it to be fairly wide, so I'm going to make the segment AB pretty small here. And clearly this is not sitting on there yet. I need to move it up. And I also need to kind of roll it to the side like that. And I can see that I'm getting closer, and to roll it a little more. And what I found was that the values that seem to work best making this very little, and this even smaller than it is now. And I'd say that's a good approximation. What I need to do is now add some points, one being here. And the most important point at this location, or off here, is to decide where does that parabola really leave the light bulb. And I'm going to estimate at about this location. So this, I will be looking at the integral from this point all along up until here. And I might add another couple of points in here just to help visualize it a little better. And so I have a pretty close approximation for this part of the curve, and I have its equation, which was very important. My next step is I will label and find the coordinates of these points. This last point is really the one I care about the most. And on your coordinates. Okay, jumping ahead, just showing how I found a circle that approximated this portion of the light bulb. I'm looking for an equation that follows the shape of the light bulb from J all the way down to R over here. And I just put in a circle and moved it around until it approximated the area that I was looking for. And when I click on that, if I go up to measure and find its equation, here is the equation for that circle. So that piece of information is very important. These two equations are the two things I will be using to integrate and find the volume for this light bulb. I now have the approximate equation for the circle. I solved this equation that it found for me for the y, and found the s of, this says s of x, and now I have the two functions, and I'm going to integrate the first and the second. The first, which is the parabola, I just want to integrate it from the starting point, which is at 0, through to my point J, so that I'm just looking at the volume in this location below. And then I will use my second equation, which is the circle here, and I will use that equation and integrate that to get the remaining portion from 1.54, the J location, over to R, which I have as 3.18. And so these two, after they're integrated, I found, and I did this on my own. You also can use Inspire or some other software to help you if you'd like, if you didn't want to use the pen and paper method. My parabola, I found to have an integration from 0 to 1.54 to yield an approximation of 4.7215 cubic inches. And integrating my second equation is going to give me an approximation of 9.4648 cubic inches. And the sum of those two will be the volume of my light bulb, which I found to be 14.1863 cubic inches. Just to note, my grid here is set up, the light bulb here has a distance from about this point to this point of about 3.25 inches. So I kind of went with this grid as being similar to inches, and so it is approximated, but it's about the right idea.